close on it here? Did you guys get the first one yet? Okay. Are we on to the second one yet? Yes, no, give me a, are we on to the second one? Not yet? Okay, we'll get there, we'll get there. Give you about one more minute here. We'll figure out where we're at. See if we can't figure this out. You guys help me figure this out. All right, let's talk on the first one here. How about volunteers for a solution on the first one? Sam, what'd you get, kiddo?
X equals -2 and y equals 8.
How many agree -2 and +8? Let's just talk about this. I would subtract 3x from both sides with the way we started here. Okay, so when we do this right here, we've got 14 equals -7x. So 14 divided by -7 is -2. So I agree with the first part. Okay, I'm just going to go to the second equation because that looks shorter to work with originally, doesn't it? It says y is equal to -4 times x, or in our case, -4 times what value? -4 times the x of -2. -4 times -2 would be a +8, wouldn't it? Make sense there? Okay, so I agree with this one right here. I totally like that. Good, very good. How about a solution for the second one? Anyone get that there? Anyone want to volunteer? Okay, let's look at this right here. I think, which variable do you want to get alone, guys? Is it possible I could get x all alone up here easily in this first equation? It is, isn't it? Is it possible that I could get y all alone easily in the second equation? I could. Now the deal is this. It doesn't matter which one you get all alone first, as long as you have one variable all alone. I'm going to go ahead and rewrite this top equation as x equals, what would I have to do to get x all alone, guys? What would I have to do to both sides of this first equation to get x all alone? Add y. So this becomes y minus 4. Okay? Now, some of you might have changed the second one and gotten y alone. You might have said y equals -2x plus 4 and use y as your isolated variable. And that's fine to do as well. Okay? I'm saying x equals y minus 4 right here. So since x is isolated, what could I put in for x right here in the second equation? What's x equal to here in this first equation? So what could I put in right down here? So I would rewrite this second equation as 2 times y minus 4 plus y, and that equals 4. So help me distribute 2 to this quantity. What have you got?
2y minus 8 plus y equals 4.
Okay. So this is 3y equals, do you agree add 8 to this side over here? I would add an 8 to the 4. 3y is equal to 12, isn't it? So what's that going to make your y value, kiddos?
4.
Going to make your y value 4. Okay, so we know y is 4, so we just need to substitute. So I'm going to go right back up in here, the one that we rewrote. What value could I plug in for y? So it says x equals 4 minus 4. We all agree with that? X would equal 4 minus 4, making x what value? 0. X is going to equal 0. Very good. X equals 0. Okay. Check it out, guys. If y is 4 right here and x is 0, look at this second equation. What's 2 times 0?
0.
Plus 4. Does that make that statement true? Okay. If I go up here, 0 minus 4, the x minus the y, 0 minus 4, is that -4? Is 0 minus 4 -4? These values make both equations true. We've got it. Okay. All right, a little bit of work involved, but I think if you say, I've got to find an isolated variable, substitute, solve, and then go back in to get the other value, I think you'll be okay. All right, questions so far before we look at this last example? Anyone, questions so far after we have done these? Okay, last example then. Let's take a look at this last example. It's very similar to what we did yesterday. It's a real life example. How about a volunteer to read that for me? I will read it. It says a theater earns $3,640 from a concert. An orchestra ticket costs 3 times as much as a balcony ticket. 148 orchestra tickets and 76 balcony tickets are sold. Write a system of linear equations that represents the situation first, and then figure out what is the price of each ticket. How much money was made? How much money was made? $3,640, okay? It says an orchestra ticket costs 3 times as much as a balcony ticket. We want to know the price of each ticket. So it looks like we have some orchestra tickets and we have some balcony tickets. Okay, we're trying to figure out the price of each ticket. Price of an orchestra ticket and a balcony ticket. I'm going to let X equal the following. X is going to equal the price of an orchestra ticket. So what's that mean Y is going to equal, kiddos? Price of a balcony ticket. Good, guys. Y is going to equal the price of a balcony ticket. That's what we're setting out to find, the price of each one of these. Okay, so get those parameters set. That's what we're trying to find. That's our unknown. That's what we're trying to figure out. Okay. I'm going to highlight some stuff. It says an orchestra ticket costs 3 times as much as a what? Okay, so if you bought one orchestra ticket, how many balcony tickets could you buy? For the price of one orchestra ticket, you could have 3 balcony tickets. Listen to what I said right here for my first equation. For the price of one orchestra ticket, in other words, 1x, whoops, 1x would equal how many balcony tickets?
3.
So for one orchestra ticket, you could buy 3 balcony tickets. There's your first equation. And this is excellent because do I already have a variable that's all by itself on one side of an equation? What's all alone? X. What's x equivalent to? 3y. So anytime I have an x down in the second equation, what are you going to replace it with? What are you going to replace the x with? What's the equivalent of x? 3y. So here's the next one, guys. Next one says, well, you made $3,640. How many orchestra tickets were sold, guys? So to know the amount of money that was made from orchestra tickets, wouldn't you take 148 tickets times the price of each ticket to know how much money was made? So to set this up, we're going to simply say, well, 148 seats that were orchestra tickets were sold at a price of X dollars each. And then to that, we added the price of some balcony tickets. How many balcony tickets were sold, kiddos?
76.
Okay, so there were 148 orchestra and 76 balcony tickets. What's an expression going to look like for the amount of money earned for 76 balcony tickets? Well, it would be 76 times the price of each balcony ticket. So 76 times what?
Y.
We're going to add in those values. And this totals up to a grand total of how much money from a concert?
3,640.
$3,640, you bet. So here we go. Have I written my system? 2 equations, 2 unknowns. Here it is. Okay, now we just have to solve. Do I have a variable that's all alone? X is all alone. What's X equal to?
3y.
X is equal to 3y. So what are you going to plug in for X right here? In the second equation. 3y. Let's rewrite that second equation. Here we go. We're going to go 148, not times X, but 148 times what, kiddos? 3y, good. And then continue the rest of the equation, plus 76y. That's equal to 3,640. Anybody have a calculator handy? This is where I'm going to struggle. 148 times 3y. 444y, good. Plus 76y now equals 3,640. What are you going to add to both sides? Or what are you going to combine? I guess that should be the better question. When we combine the y's, guys? When we combine the y's, guys?
520.
How many? 500? Grace, are you ahead of me? Have you divided that already?
Yeah.
What'd you get when you divided?
7.
Okay. So it looks like the price Y, it looks like the price of a balcony ticket is how many dollars, guys? $7. Okay, and I'm going to kind of do this quickly. Okay, so Y is equal to 7. Once I know Y is equal to 7, I'm going to run over to here. If Y is equal to 7, I'm going to choose of these two equations the shorter one to substitute back into. I'm going to use the top one to figure out what X is now. So in this equation, X equals 3Y. Well, do we know the Y value already? What was your Y value here? 7. So couldn't I plug 7 in right here? So X is going to equal 3 times 7. So X is 21. So to put this all back together, here, I'm simply going to say at the bottom, X represented the price of an orchestra ticket, right? So how much is an orchestra ticket, guys? $21. And then how about your balcony ticket? How much is that?
$7.
Okay, very good. A lot of stuff going on there. Okay? A lot of stuff going on there. I'm kind of looking at Monday as being kind of a work day over some of these first couple of sections that we looked at in Chapter 5. What I'll do is I'll send 5.2 out to you. Remember, 5.1, when's that going to be due for you? Monday. 5.2, when I send this out here in a little bit, that won't be due until Tuesday. And I think we should be good. Okay. Any questions for me at all today? You guys did an awesome job today. Keep up the good work, all right? Don't forget, when are test corrections due? Monday. If you want those points, get into JMC, check that out. Remember, test corrections, separate sheet of paper.